Okay, so we're on to structural change. So, in Solo, what's the potential for structural change? In a word.
For structural change.
Yeah, structural change is these shifts in consumption patterns and stuff.
Limited.
Very limited. Can you be more specific?
0.
0, yeah. And actually, you can get sort of blinded. It's like the old cliche, you know, if you've only got a hammer, you see nails everywhere. You can kind of forget this. You're just doing your macro, and this is your way of looking at things. And it's easy to forget that, wait, you know, there's this other potential explanation that is completely ruled out from the start in the models we're using that is about patterns of consumption for different goods. There's only one good here, isn't there? The widget, or whatever you want to call it. What about in DHSS? What's the potential for structural change in DHSS? It's 0, okay, right, nothing changes, yeah. There's still only one product. Okay. And we can, if we sort of say, oh, okay, yeah, but we didn't like DHSS, you know, we had this kind of thing with directed technological change, what's the potential for structural change here? It's not, there's nothing here either, right? In a way, I showed you that if we delved in depth into the DTC, directed technological change, the sort of math and the details of that model, we had this bunch of different firms making different products. But we didn't, so there's almost, we were opening the door a little chink for structural change, but in the end, all the products end up symmetrical with the same properties. They're just, there's something different about them that means that consumers want a range of products and not just all of one. But that something has nothing to do with resource intensity. Okay, in the models we've looked at. So clearly, given what we've concluded from our study so far, we need to investigate. We need to build models which allow for structural change. And then try to work out if this is potentially a helpful way to understand what's been going on and a helpful way to predict what might happen in the future. Okay. But I kind of, in the end of the last lecture, I sort of said, look, DTC isn't going to do the job, and then I kind of waved my hands around and sort of said, well, it must be structural change. But do we have any, if we just look at what's been going on for the last 100 years, is there kind of, do we see that kind of structural change going on? Do we see shifts in consumption patterns? Or do you think, like, when you look at what you're consuming today and what people consumed 50 years ago or 100 years ago, is it like that you're consuming more or less the same, but just more?
No. But
So what kind of stuff are we consuming today compared to what they were consuming 50 years ago or 100 years ago? What sort of shifts do we see?
More necessary stuff like or like the unnecessary stuff like technology and so on. Trips.
yeah.
So technology is a bit vague, but travel is that's what you meant, right?
Yeah.
Yeah.
Like traveling.
So we probably spend more. The proportion of our income that we spend on travel might have gone up. How do we travel? Is that the same? Are we using the same means to get from A to B? So if we look at passenger kilometre or person kilometres per year, with the proportion, and you look at different modes of travel like walk, ride a horse or horse and carriage, bike, car, small car, medium car, big car, truck, train, bus, plane.
That might have changed somewhat.
So what kind of changes would we expect to see there in terms of?
Don't travel a lot more by airplane.
So certainly in terms of a plane, like the percentage of person kilometres travelled by plane 50 years ago would be like 0.001 or something. It was basically around about 50 years ago the whole passenger air travel started. It kind of started in the 60s, you could say. I mean, the absolute first, completely, it started from zero, like in the 50s. So that must have increased massively, obviously, in percentage terms, from like 0.0001 or something to whatever it is today, 10% or. If you look at the kind of, if you think about car compared to train and bus and bike,
There are more and more people getting cars, and maybe like bigger and bigger cars, but still the cars may be more efficient.
yeah.
But yeah,
But here we're only looking at the quantities, yeah. So if you think about the train network, of course, we're basically running on the same network today as we were 50 years ago in Sweden, I guess. In the UK, the train network has actually shrunk massively at least since the 60s. We got rid of about half of our train network. It's called the beaching cuts. Meanwhile, we're building up our road network the whole time, right? Massively. So of course, it's like quantity, mode, and what the stuff if we're train travel's not going up as fast as say car travel over that 50, 60, 70 year period. So car travel would have gone up like massively more than train travel, I would claim. I haven't done the data on Sweden. Is that going to mean everything else equal? Is that going to mean more energy use or less? For the same train and the same car, which uses more energy to get from A to B? Right. So switching from train to car is driving energy use. Yeah. Switching from like other stuff to international travel is driving increases in energy use. These are energy intensive sectors we're shifting into, right? And of course, if these sectors are growing as a proportion of GDP, there's other sectors that must be shrinking. Yeah? And if it's the energy intensive ones that are growing, then that's the less energy intensive ones are shrinking, and this is suggestive that our kind of hypothesis that structural change could have a lot to do with this, maybe this is more kind of suggestive evidence that this may be correct. Did you want to say something?
well, I was thinking, of course, in some cases it has to be shrinking in other sectors, but isn't it also that we have started to consume more?
Yeah, but the proportion is shrinking.
Okay. Yeah. Okay.
The proportion. So a lot of the time here I'm talking about Y is growing, but then we're talking about the proportion of Y that is made up of different things. Because if Y grew, but the proportion stayed the same, and this is growing fast, then we would have, instead of this, we would have this. Yeah. If this is growing really fast. And it seems a lot of the time that this is growing pretty fast. But still, if you think about the cars we're using, so we're driving more, but what happens, what's changed, if you look at the average power output of a car today compared to in the 60s, say, what would the difference be?
Higher power.
Right, and would this be like 10% higher power, or?
Say almost double probably.
more.
I guess it would be like 5 times that or something. It's like in the old, even when I was a kid, if you wanted to sort of overtake, it was like, you have to plan 5 minutes in advance. Sort of hang back from the car in front and then accelerate up and then hope when you get to the straight bit that you know is coming, there'll be nothing coming the other way and then you can get past. These days it's like, you're off, ooh, Of course, you could get powerful cars then too, but if we're talking about the average car. So there's a lot of straws in the wind, as we say in English. There's a lot of things that, just vague observations that you might think support this idea. There's some data, it might be in these notes, actually I'm not sure. There's a paper, it's certainly in your reading, on lighting.
On what?
Light,
Light, okay.
artificial light. I think it's on a 100-year perspective, and it's one of these sort of economic historian kind of guys who goes delving into old records and then tries to piece together a big picture from some point estimate. And it's a while since I looked at the data. Yeah, so the one thing that he does is work out how much more efficient lighting has got, sort of average or typical lighting from 1900 to 2000, I think it is, in the UK. So how much more light in lumen per minute or whatever, or lumen, now how many more lumens could you get out of a lump of coal, kind of, or a certain amount of primary energy? So any guesses, what would the increase be? What factor should I put here? Like 2? More than 2.
Let's say 100.
Okay, anyone else? Any advance on 100?
101.
You're right, it's more than 100. It's actually 1,000. Okay. Which isn't that surprising when you think of candles, and maybe the typical people, they might not even have had proper candles, they might have had sort of tallow, like up to there. Pad, tack. And obviously now, we've got these LED bulbs and whatever. So this is an extreme case with a massive efficiency increase. And if this was reflected, of course, in the aggregate, then energy use would be like, if that was across all sectors, this corresponds to whatever, 20% a year or something. GDP is growing by 3% a year, energy use is going to fall by 17% a year, roughly. But over the same period, how much more light do you think we produced? I think this is per person. I can't quite remember. In the UK. According to the paper, so there's a number in this paper, but times 2? You think times 2? Anyone want to have a guess?
100 again.
Go for 100. What do you say, Alexander?
99.
99? No. Aye, no.
It's more.
7,000.
Aha, okay. Okay. I just thought, yeah. I get it that it is with cars and stuff, but I didn't think about it with lighting.
So in the old days, you'd be sitting there with your one candle in the evening, kind of trying to read.
Right.
And now it's let there be light. It's a phenomenal difference. And now this is for 2000. It's probably at least doubled since then.
So it's like lumens per person.
Per year, yeah.
Okay.
I'm pretty pretty sure it's per person. Otherwise it would be 3,000. If it's total, it would be 3,500 per person. Because population is roughly doubled in the UK. This is UK. I don't know exactly, but I think we're around 30 million at the turn of the last century, previous one, and then it was like around 60 million in 2000. So it's not crucial. So as you can see, what's happened to energy use in that sector, according to this,
Increasing.
by a factor of 7, isn't it? Oh no, my phone's...
I do got a charger.
Yeah, I think we'll just have to hope for the best. Oh yeah, we're running out of time anyway. Okay. So there's plenty of reasons to think this structural change could be super important. But then we want to actually understand what's behind it. Like, why do we shift between these different products, right? Because if we want to make predictions and so on, we want to understand what's been going on and make predictions about the future. It's not enough just to say, oh, it's structural change. We want to know why there's been structural change. It's like with the directed technological change. It's not just with, oh, there's been directed technological change. We build this model to explain why there might be, and then once we've got the model, we can say, oh, actually, that doesn't make sense. We want to nail it down, our explanation, and then we can then test it and make predictions and so on. And of course, this is really tricky. Structural change is really tricky. It's like the lamppost picture, yeah, with looking for the keys or whatever it was. Economists tend to like a macro. Oh no, let's just have one product. So this is kind of tricky. But what kind of things do we want to? What kind of explanations could be behind structural change? And basically, there's two. If we're staying in the mainstream of economics and assuming that preferences are stable. So, agents have these stable preferences over different goods, and then they choose based on two different things. So if you've got some basket of goods to choose from, and you think, oh, shall I have some of this, and I shall have some of that? What two factors are going to affect what you choose according to the standard economic model? So you got this basket of goods. And you're wondering what to buy. Shall I have some of this? Shall I have some of that? So one of them is super obvious, right? Can you explain a little bit more in detail? The relative prices of these goods, yeah. So that's kind of explaining this individual's choice at any given time. But then if there's this one chooses a certain thing, but then maybe this one a bit later chooses something else. Or maybe just someone else with some different characteristics chooses something else. At the most basic level, what is the difference?
Their preferences between goods or their utility.
Generally, that's not what I'm after here. Okay, I'm thinking at the most basic level, we sort of often assume that, maybe I'm just making this unnecessarily complicated. What else can differ? It's not that, of course, people can have fundamentally different preferences.
The substitution ability.
So I think I'm going to someone said something about substitutability, but someone else said something else.
I said income, but I don't know.
Right, yeah. So that's what I'm after. Okay. Sorry to make you kind of searching in the dark, but it's like relative prices and the income. Okay, I'm drawing this out because I want you to remember it because it's important. Okay. This is like the classic thing, isn't it? Is it a substitution effect or an income effect? You know, it's the kind of question you get looking at in sort of micro. When the pattern of consumption changes between two goods. So, have we switched to bigger, more powerful cars because they got cheaper compared to other stuff in the economy? Or did we switch to them because we got richer? And rich people like big cars. Okay. This is kind of important for policy, isn't it? Because if it's this, then people are kind of sensitive to relative prices. If it's like 100% this and 0% that, then that means if you just raise the price of this sort of bad stuff, if you want to get energy use down, then that will have quite a big effect, right? But if it's just this, and people, just rich people, I'm gonna have that powerful car, and you're insensitive to relative prices, then it's like, you tax the powerful cars, it's hardly going to have any effect. It has a very small income effect, because effectively, when stuff you want to buy gets more expensive, that is effectively reducing the value of your income. But that effect is small compared to actually having less income. So depending on which of these is true, the effect of policies like taxing energy-intensive goods is going to be very different. And also, imagine if you raise AR, if your policy is to try to boost AR, and this is the key mechanism, there might be a problem, mightn't there? What would that problem be? Have a think about that. So this is the key mechanism. You want to bring down energy use and you raise energy efficiency.
They might be more expensive to buy. The ones that you boost the AR in. No.
A bit more thinking.
It would become cheaper and therefore people will be able to consume even more or like the same amount.
Yeah, so you're kind of in the right ballpark but running in the wrong direction. Yeah? Because if you say you make car producers, you introduce regulations that push them to make their engines more efficient. But then it's cheaper. Part of the cost of buying a powerful car is that it needs more fuel. But if the technology to turn fuel into power gets more efficient, then the extra cost for the more powerful car is lower, right? Because the car engine got more efficient. It's almost a cleaner case if you think cars are kind of tricky because you buy the capital good and then you buy the fuel. It's kind of complicated to think about. So it's almost cleaner actually to think about air travel. So you make airlines introduce stuff that makes the planes more fuel efficient. Once they've done that investment, or if you even imagine doing that investment for them somehow, what's going to happen to the price of the plane tickets? It will go down, right? Because they're using less fuel, and this is a very energy intensive sector. Fuel is quite a big part of their costs. So the planes got more efficient, fuel wise, price of the tickets went down. If that's the key to people's demand, if they're very flexible and really care about relative prices, that will push people into flying more. That's called something. Anyone know what that's called? It's called rebound. Rebound. And if they fly it's quite clear that there will be some rebound, you know. But then the question is like how much? Is it like 1%? So the 99% of the sort of expected reduction in fuel efficiency actually happens, and 1% gets lost from rebound. Or is it like 100%? Or it could even be more than 100%. That people fly so much more that you end up using more energy than you did before. That would be called backfire. So like in the lighting sector, we're using more energy in lighting than we were before. Is it because if that is all driven by lighting getting cheaper, then we've got a problem, kind of thing. Okay, so this has a lot of policy